That makes sense to start with the domain question though. So let's talk about the domain of this. We have a square root. We know that our stuff in the square root has to be greater than or equal to 0. We also have a denominator. We know the denominator can't equal 0. So we set it equal to 0 and then solve. And let's say we're going to get x equal to 25. Thanks. So our domain here is everything bigger than or equal to 0 with the exception of 25. So when I go 0 to 25, and then everything from 25 onward, excluding 25. We could try to talk about the range, but it's a little I mean, we will try to talk about the range, but usually talking about the range without the graph can be somewhat complicated. If I were trying to find the range of this and I didn't have any tools, right? Like I didn't have a graphing calculator, I didn't have Desmos at my disposal, here's what I would probably do. I got a fraction. So I'm going to think about kind of what things I can get in the top and what things I can get in the bottom. I know that, use another page. I can write smaller, I guess. We'll go out and we'll come back. We were about to talk about how you might find the range of this function if you didn't have any other tools other than your widths. And here's what I would first make note of. When you've got fractions, there's often one number you sometimes can't get. And usually that number is 0. And you cannot get this equal to 0 because the numerator can never be 0 here. If you look at that numerator, e to the x is always is actually always positive, and e to the x plus 1 is always greater than 1. So I would observe this is never going to equal 0 for sure. So without a doubt, the range is limited. 0 is outside of the range. But then it gets a little bit weird. Here's what I would say. I know that e to the x plus 1 is always greater than 0. Sorry, is greater than 0 plus 1. So, yeah, you could probably do some wacky stuff here. I guess I might try doing the whole, I'm like really like, honestly, I don't know how you would find the range necessarily without any other tools. I'm trying to think about it, but like, so this is actually, we're even more limited than that, because if we start with our domain, x being bigger than or equal to 0, and x not equaling 25 plus 2, by the way. Yeah, yeah. I would graph it. I'm like, I know I said what we would do if we didn't have any other tools, but we'd look for the other tools, because finding the range of something like this is maybe really hard without any other tools. Like you could try to find the inverse of the function. That's what people do, but finding the inverse here is, I don't think, really plausible. Yeah. Oh, of course, yes. Sorry. So let's see what the graph looks like, because I'm curious now. I mean, I'm always curious, but you know. Let's see. So we got f of x to e to the x divided by. I find it convenient to do the divided by part first, because if you don't do that, then you often end up with stuff like not in the numerator, but you want in the numerator. Okay, well, that's interesting, but maybe we should zoom out a little bit. That's, oh, so yeah, so if you look at this not very carefully, you would think, well, the range is starting at that, but we're actually not getting that value, right? That is not included because x can't, oh no, it is included. I apologize. Yeah. So if x equals 0, the y value is going to be e to the 0 plus 1 over the square root of 0 minus 5, which is 2 over negative 5, which is negative 0.4. So if I had to guess with this limited information here, I would guess that my range was, now this is going to be not all the way right, but I would guess that my range was everything from negative infinity to negative 0.4, inclusive. But that's not right. Oh, sorry, question. Oh, you can't see the thing. Yeah. Please let me know, like, feel free to just be like, James, I can't see you. Do the thing. Yes, I will do it always. But what I want to mention is that is not the whole story. Let me point out, if x were bigger than 25, so if x were, say, I don't know, if x were 26, f of 26, that looks terrible, I know, would be e to the 26th power, which is a gigantic number, plus 1, tiny bit more gigantic, divided by the square root of 26, okay, which minus 5. And although I have no idea what this number is, I know it is extremely positively large, because the numerator is definitely a big positive number, and the denominator is also a positive number. And square root of 26 is a little bit bigger than 5, so that denominator is positive. So what's happening is Desmos isn't able to tell us the whole story really, because when we get over here to being bigger than 25, the y value is so large that we just can't see it. That's the problem. And then the thing is, if that's going to happen, right, the further out we go, I mean, I can click on this for a while, and you can finally start to see it. Whoop. So that's super helpful, right? No, it's not super helpful. So kind of interesting that it's hard for, can we go? Can we go? Can we go? I really want to see where the bottom of this thing is, but I don't know. It's somewhere not very helpful. Okay, well, so clearly this is not getting us anywhere because our scale is too big. So sometimes it's really hard to see what the range is, I guess, is the moral of the story, right? We could do a lot more work and maybe figure out what the range of this is, but that doesn't seem like a really good use of our time. So the range here is, I don't know what the rest of it is. Maybe we'll never know. That's okay. Sometimes things aren't knowable. It's probably knowable. It's just a lot of work to find. Saw someone out there. All right. Well, let's move on. The main range, useful stuff. Well, let's talk about. So the problem with this class, one of the issues at the beginning of this class is there is kind of a lot of just pre-calculus stuff. People are like, oh, let's talk about this, let's talk about that, let's do this. So like we could talk about a number of different things. But here's, I think, something good. Let's say I want to describe, or actually really find, a sinusoidal function. Ah, yes, thank you. That starts at a value of 300, then has a low of 50, then a value of 300 again, and then a high of 550. We want this to have a period of 7 days. Anything else I'm missing from that? No, I don't think so. So I should be more specific. At time equals 0, we want the function to equal 300. And at time equals 7, we want that value again. So when I see a function, so first of all, the word sinusoidal, what does that mean? Also, I'll just point out, I'm certainly happy. Anyone is welcome to take pictures anytime. I will post these notes to Google Drive later, so you are certainly welcome to, but you don't have to if you don't want to. Sinusoidal just means it's a sine or a cosine function, either one. It has that usual sine / cosine shape. And we're kind of given a lot of information here. I know it's supposed to start at 300. And then it's going to go down to a value of 50, and then back to a value of 300, and then up to a value of 550, and then back to a value of 300. So it's going to look something like this. And our job is to figure out what the function actually looks like. And I think we can see a lot of the things here. We can see that the amplitude, the way I think about the amplitude is it's the total length of the range cut in half. So how long is, what is the range here? From how low to how high? Right, and so what's the length of that? 550 minus 50 is 500, which means the amplitude is half of that. There's a number of other ways to think about it, but I feel like that way is always very succinct.
Is that how you would write it down to like remember what you just said? Like what you said?
Yeah. So you can think of it as 1/2 of, bless you, 550 minus 50. 1/2 of the difference in the y by the top and the bottom. Or, right, there's a number of other ways to find it. You could say it's the distance from the middle to either the top or the bottom. And then I guess we could start writing it. So the thing is, we have to know which trig function this looks like. I mean, technically, it's really anything. You could say it's cosine if you do the right horizontal shifting. But I'm trying to pick the one that I'm not going to have to do that for. And I see that that looks like sine, but flipped over. So this here to me looks like a negative sign of some stuff function. So I see that I have, okay, negative, well, I know I want my amplitude to be the coefficient. Your question? Okay. So I have negative 250 times sine, and we're going to work this part out. And then I also will, if I do negative 250, that's going to have a bottom of negative 250 and a top of positive 250. So I need to add on the vertical shift, which is 300. And that should get us our lows and our highs, right? The smallest sine can be, and this is actually worth, this is, I think, worth saying this in general. It is true that sine of anything is always between 1 and -1. So if you multiply that by negative 250, it's always going to be between 250 and negative 250. And if you add 300 to it, it's going to be between 550 and 50. But we need the period to be right. And really, the way I think about it is the period is always 2 pi divided by the coefficient of that variable there. That's kind of the way I've always thought about it. There's probably other ways to approach it. So I'm going to try and make this equal to 7 days. Oh, sorry, thank you. And then I'm going to solve for the b coefficient there. So I'm going to multiply both sides by b. I'm going to divide both sides by 7. So that's what needs to go right there. So you can always find that coefficient by just doing 2 pi divided by your period. It'll always work that way. So my function here that meets all the criteria is going to be negative 250 times sine of 2 pi over 7 t plus 300. And you might do a little check just to make sure your first value is right. If I plugged in 0 for t, what's sine of 0? That's a good question. What is sine of 0? So here's your quick unit circle. Here are the points: 1, 0, 0, 1, negative 1, 0, 0, negative 1. Here are your angles: 0 radians or 0 degrees, pi over 2 radians, which is 90 degrees, pi radians, which is 180 degrees, and 3 pi over 2 radians, which is 270 degrees. And then this is also 2 pi radians, which is 360 degrees. The unit circle tells us the value of sine and cosine. Specifically, the way I remember it is alphabetically. The x coordinate comes before the y coordinate alphabetically, and cosine comes before sine alphabetically. So cosine is the x coordinate, sine is the y coordinate. So sine of 0 radians is 0. Cosine of 0 radians is 1, and so on and so on. Sine of pi over 2 radians would be 1. Cosine of pi over 2 radians would be 0. So this is useful if you try to remember the nice quadrantal angle values for your three functions. And we can see that sine would go 0, 1, 0, negative 1. But we did negative sine, so it's going to flip over. So instead of going middle, top, middle, bottom, middle, it would go middle, bottom, middle, top, middle. Right? Because you're getting the sine, then we're going this way essentially. Sorry about that. So that's how you might approach a problem like this. And again, and I'm saying this a lot, there are lots of ways to do things, right? If you have a different way of doing it, that is also all right. It's more than all right. You guys have any questions about this so far? Like you should interject with questions whenever you have them. That's a good one, sure. Also, I was looking at one of these homework assignments for, I think the one from Guy, I printed out, and like, it was like, you are working on a new temperature scale that will unify the Earth. After some thought, you decided to call it the James Parmenter universal scale. I'm like, wait, did he use mine? I don't think, oh no, that's what that fills in for you. I was a little worried, like, I don't think he knows me that well. Why is he making me the part of his problem? Especially my last name, it seems a little weird. But then I realized it was in boldface, so. I'm happy to look at homework problems and just modify them. Also, typically everyone gets different numbers on theirs anyway, so I'm going to look at mine. Let's look at this problem. Assume the number of seeds a plant produces is proportional to its above ground biomass. Okay, so let's write some stuff down. And I would encourage you when you're doing problems like this, especially the ones that are lots of words, like this one is. Can't really see that very well. Let's zoom in. Maybe. I don't know why the zoom button is very kind of finicky. So, right, there's a lot of words here. I'm going to write stuff down as I go. So assume the number of seeds. So let's say that S is the number of seeds is proportional to the above ground biomass. Let's say B is the above ground biomass. It is good to label your things. And I know that S is the number of seeds is proportional to that. So when something's proportional to something else, it is a constant multiple of it. If a plant that weighs 228 grams has 23 seeds. They tell us to use so they told us to use different variables. Use the variables S for number of seeds and weight for W for weight in grams. Okay, fine. You can use a W instead of a B. So we have S equals K times W. And then we are going to use the information they told us. We know that when W is 228, S is equal to 23. That's not a terrible problem. All we're going to do now is use these numbers to solve for K. So I'm going to write that 23 equals K times 228. And then I'm going to get K equals 23 over 228. And I would definitely, I would like for you all to see that maybe. I would definitely recommend not getting a decimal approximation unless someone asks you to. So you want to be as exact as possible when you're doing these things. The number here is 23 over 228. It doesn't really simplify. That's just it. On the other hand, if it was like 23 over 230, we would simplify that to 0.1 or 1/10 or whatever you felt was convenient. But this is kind of it. So then our relationship is S is 23 over 228 times K times W. Apologies, right? I'm plugging in for K, not for W. Sorry, I know it looks awful. That's the idea then. So when things are proportional, one is just a multiple of the other. And this is supposed to be always true. So if the weight was 0, the number of seeds would be 0. If the weight was 10, if the weight was 10 grams, the number of seeds would be 23 times 10 over 228, which would be just slightly larger than 1. It's interesting that, right, because so all this, although this is definitely the way we want to answer this question, it's weird to say you would get a fractional number of seeds, right? You don't get like half a seed. You don't get 2/10 of the seed. So there's some refining that could be done to this later on where you talk about like the number of seeds is actually the biggest whole number less than or equal to this thing here. That's a nice piecewise function we can talk about later. Okay. There's one other thing I saw in here that I thought was really kind of useful. Let me just double check. Where'd you go? Sorry. There's so much information. Oh yeah, that's what it was. So let's talk about papers everywhere. Don't worry, eventually I will see more organized. Yeah. That is from Guy's homework, yeah. Now your problem, and my intention is not to exactly do the homework problems. So I changed the numbers around a little bit, but the numbers could end up being the same as the numbers you have. They could be different. The ideas are still the same, though, and that's what's important. I thought this question was interesting. So we're going to express the function. We use a capital F here. F of x equal to x to the 4th plus 1 over x to the 8th minus 2 in the form f of g. And they're asking us, what do we pay for f of x? What do we pay for g of x? Yeah, I can. And the real answer is there are a lot of different answers to this type of question that would all technically be correct. Ranging from the very kind of annoying to the perfectly fine. One perfectly good answer, although not what they're looking for, it would be something like this. Now, this is going to be, if my student wrote this, I'd be like, okay, come on. I know you're just being annoying about it. But you could say, all right, g of x is going to be x, and f of x is going to be x to the 4th plus 1 over x to the 8th minus 2. That would technically be correct. Because I don't love the circle notation here. I prefer the parentheses notation. But f of g of x is, well, that's going to be f of x. And f of x is exactly what we want it to be. That's not what they're probably looking for, really, though. Like I bet WebWork might not even accept that answer as correct, because here's what I bet they're really asking for. They probably want you to let, say, the inner function be x to the 4th. That's what I would guess if I had to guess. Because if the inner function, which is g of x, is x to the 4th, well then f of g of x is going to be f of x to the 4th. I just need to put an x to the 4th in. So that's kind of weird. How am I going to get that to work? So I want this to be that, which you can still see good. So if I'm plugging in x to the 4th, well, I want to get out this. And x to the 8th might be useful to think of as x to the 4th squared. So what I'm doing here is I'm making the choice that the input is x to the 4th. I'm still writing the output as what it is. I'm changing it a little bit so I can see where the x to the 4th go. So check it out. If f of x to the 4th is f of x to the 4th is x to the 4th plus 1 over x to the 4th squared minus 2, what I'm going to do is I'm just going to take the x to the 4ths and replace them all with x. So I'm going to instead write f of blank equals blank plus 1 over blank squared minus 2. But now put whatever you want for the x to the 4th. I'm going to put in x. And now we can see, oh yeah, f of x is just x plus 1 over x squared minus 2. And if we input for the place of x our g of x, and if that goes in there, then it goes in there, and it goes in there. And then you exactly get the thing. And this is probably the answer that they're actually looking for. But you could totally make up lots of other bizarre answers to this question that would technically be correct.